Hello and welcome to video 5 in this series about mathematics for machine learning. And today it's time for matrix multiplication. And matrix multiplication is the fundamental operation in machine learning. That's because weights and inputs of neural networks are usually represented as matrices or tensors, so a lot of matrix multiplications are performed during inference and training processes. So if you know what the vector dot product is, this tutorial is going to be quite easy. And if you don't, I have made a video about it, so be sure to check it out. The link is in the description below. A matrix is a rectangular array of elements. It has rows and columns, and a matrix with 3 rows and 4 columns is a 3x4 matrix. Matrix multiplication is a way to combine two matrices to get a new one. To multiply two matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Let's say we have two matrices, A and B, and we want to get a new matrix C by multiplying A and B. We see that matrix A has 4 columns and matrix B has 4 rows. That means we can multiply them. To compute the first column of our matrix C, we take the first column of matrix B and compute dot products with every row of matrix A. In this case, we'll get 3 dot products as there are 3 rows in matrix A. Now we take the second column of matrix B and do the same process once again. That's it. We performed matrix multiplication. The resulting matrix is 3 by 2 because matrix A has 3 rows and matrix B has 2 columns. And the same process can be performed for matrices of any size as long as the number of columns in the first matrix matches the number of rows in the second matrix. If the input matrices are m by k and k by n, the resulting matrix will be m by n. And with matrix multiplication, A times B is not the same as B times A. This is a big difference between multiplying scalars and multiplying matrices. This is a simple example in Python. At first, we initialize a matrix with the same number of rows as the first matrix and the same number of columns as in our second matrix. Next, we have a triple nested loop, and here we iterate through row indices of our first matrix, in the middle loop indices of columns of our second matrix, and the innermost loop iterates through row indices of our second matrix. And in this line, we basically accumulate the dot product of the required row from first and column from second matrices as we multiply specific elements while this k value changes. But you can do all that using NumPy with a one-liner. There are different ways to do that, but the same dot operator works. Or if you like, you can use the matmul function. And as you can see, it works as expected. If you find this video useful, hit a like and consider subscribing because there are more videos to come. And that's it from me for today, and I'll see you in the next one.